Continuing with our circles, today we're going to continue talking about tangent circles. So today, tangent circles or tangents intersecting with the circles, remember they touch at one spot, they can intersect at 0 places, 1, or 2. For example, if they line up just like this where there's 2, they kind of intersect a little. They intersect at 1, 2. So these are tangent lines that they intersect at 2 places. The next one is 1, but however the last one it's 1, 2, 3, and 4 spaces. And we'll get into more of this. So first things first, tangent circles. So tangent circles are circles that are on the same plane that intersect at one point. These right here are tangent circles. They look exactly like the picture above us. After that is concentric circle. And concentric circles are circles that are inside of another. So there's one circle, and then there's another circle on the outside. And in this case, there are 0 tangent lines that they intersect both circles. The next one is a common tangent. And a common tangent is a line or a segment that is tangent to both circles on the same plane. So for example, up here, these are common tangents. So these up here are common tangents. All these lines that we drew up here. Or we can say, hey, here's 2 circles. A common tangent. Usually on the outside, we draw straight lines, like solid straight lines, and then the inside we draw dotted lines. So these are dotted, and then these are dotted. A common internal tangent, so a common internal tangent intersects the line on the inside, and basically we know it's internal. So if we look up the picture here, and I drew dots for the center of the circle, and I connect them using a segment that connects the 2 centers. If the tangent line crosses that line, then it's an internal tangent. And if it doesn't, that's why it's an external. So that's why we draw the ones on the outside with a straight line, a solid straight line, to indicate external, and the dotted line to indicate internal. So a common external does not intercept that segment. Okay, so let's try it out. See how many common tangents, draw them, use solid lines to indicate external, and dashed lines to indicate internal. So here on the outside, this is external, and the inside are internals. So this has 4 lines. This here, outside, it has 2 2 for sure, external. And on the inside, you notice how the two circles kind of only touch at one space. So here, this has one internal, total of 3 common tangents. And number 3, it has 1 and 2 external tangents. Next theorem is our tangent line to a circle. So tangent line to a circle, which basically says if there's a tangent line to any circle, so it drew a circle, there's a tangent line. That tangent line where it hits the point of tangency, it is always perpendicular. So if this is line, we'll call this line M, and this is circle A, we can say that line M is perpendicular to circle A. On down, an external tangent congruence. What it basically means is that if there are two, from one circle, if you have two lines that are tangent and they touch to the same circle, like that. So if I say A, B, and C, we can say that from A to B, it is the same distance from B to C. So AB is congruent to BC. That's all that means. So let's try this out. We want to solve for x using those theorems. So first things first, number 1 is external tangents. So we can say 2x squared plus 4 has to equal, because they're congruent, 22. I'm going to subtract 4 to both sides. 2x squared equals 18. Divide by 2, divide by 2. X squared must equal 9. If I square root this number, x is then 3. Well, that's inconvenient. Number 2, our r and r is the same distance, but I know that here this has to create a 90 degrees. So I'm going to use my Pythagorean theorem, which basically says this is my hypotenuse right here. So if I use my Pythagorean theorem, 80 squared plus r squared must then equal 50 plus r squared. I'm going to square one side, so 6,400 plus r squared. Now I'm going to FOIL the other side, which is this first number squared, 2,500. This times r, 50r, double it, so that's plus 100r, and then plus r squared. I'm just going to go through the steps. I'm going to subtract r squared to both sides. This gives me 6,400 equals 2,500 plus 100r. I'm going to subtract 2,500 to both sides, which is 6,400 minus 2,500 gives me 3,900 equals 100r. If I divide both sides by 100, r then is just plain old 39. Next things up, external tangents, they are congruent, so 3x plus 4 equals 28. Subtract 4 to both sides. 3x is then 24. Divide both sides by 3. X is then 8. Same thing here, number 4. 5x minus 8 must equal 2x plus 7. Subtract 2x to both sides. Then 3x minus 8 must equal 7. Add 8 add 8. 3x is then 15, divide by 3, divide by 3. X then is equal to 5. Finally, is it possible? Are the tangents actually tangent? Well, in order to do that, we need to use the Pythagorean theorem. We square the small ones and add together, and we see if they equal the longer one. So 35 squared plus 12 squared, does it equal 37 squared? So we're going to just type these into the calculator, and this gives me 1369 on this side and 1369 on this side. So yes, because they're the same. Let's try the next one. Does 48 squared plus 20 squared, does that equal 60 squared? 48 squared, and we punch these into the calculator. This gives me 2704. 60 squared gives me 3600, so they do not. So this is a no.